Example 6 on page 544, solve this radical equations. Solution: square root of x minus 3 plus square root of x plus 5 equal to 4. Now, to solve a radical equation, you need the radical to stay on one side, isolate to one side. That's how we usually approach. But this time we have two radicals. So we need to separate one radical on one side of the equation, the other radical on the other side of the equation. So you can move either this or this to the right. Let's try to move this and see how it's like. So to remove this radical, I will subtract radical x plus 5. Okay. So this is example 6. So subtract this on both sides. We have radical x minus 3, this is 0, equal to 4 minus square root of x plus 5. Okay? Now, when I have each radical on either side of the equations, I'm ready to use the principle of powers, which say that if A, the equation A equal B is true, then you can raise both sides of this equation to n power, and you still have the left hand side equal to the right hand side. So now this n right here is some natural number, and we use the n based on the radical that is given in the equation. Since we have square root, so index is 2, I'm going to use n equal to 2. Okay, so I'll raise to the power of 2 on both sides. Square root of x minus 3, 4 minus square root of x plus 5. Now, square root, when you square it, you can simplify the square root to x minus 3 equal to. For this, I'm going to use the squaring binomial formula. We have a minus b squared is equal to a squared minus 2 times a times b plus b squared. I'm going to use this formula for the right hand side. I will have a squared, which is 4, 16 minus twice times a, which is 4, times b, which is square root of x plus 5, okay, and plus b squared. B is the square root of x plus 5, okay. Alright, this is still x minus 3 equal to, now simplify as much as possible, 16 minus 2 times 4 is 8, square root of x plus 5, and then the last term here, again, this is square root, right? Index is 2. When you square it, you simplify the radical, so you're left with x plus 5. Okay? Then simplify what you can. Now, and you see, we start with two radicals, right? Using this principle of power, we simplify all this, and now we're left with only one radical, which is good. That's the plan. So we go from 2 radicals to 1 radicals, and then from 1 radical to 0 radicals. So that's the plan. So now let's simplify as we can. This still x minus 3 equal to 16 plus this constant right here, 5. They're like terms, so you combine. 16 plus 5 is 21. This term stay because they're different. You cannot simplify it. 5 plus x, okay, 21, negative x, square root of x plus 5 plus x. Alright, now, again, because we have radical, right, your goal is to isolate this radical term alone on one side. So let's move or remove all these two terms to the left, okay? So subtract 21, subtract x, subtract 21, and then subtract 21. Let's constant go with constant, okay? Subtract 21. and then subtracts x. This is 0. Negative 3 subtracts negative 1 is negative 24 equal to, this is 0. This is negative square root of x plus 5. This is 0. Alright. Now we're left with only one radical, which is good. Now not only that, you see that a and 24, you can simplify, right? Because 24 is a multiple of a. Since 24 is equal to 3 times a, which is 24, right? So I'm going to simplify and make the number smaller by divide both sides by negative a. Okay, if I do that, 24 divided by negative a is positive 3, okay, equal to negative a divided by negative a is positive 1. Because negative divided by negative 1, a divided by a is 1, so 1 times 1 is 1. 1 times square root of x plus 5 is square root of x plus 5. Do you see that it looks so much better when you have this form? You no longer have negative, and you no longer have this coefficient term h right here. Once you divide by negative a on both sides of the equation. Alright. We're almost there. We start with an equation with 2 radicals. We're down to 1 now. Alright, now our goal is to remove this radical. So 3 equal to square root of x plus 5. Using the principal power, you're going to square both sides. Again, the reason you square because you're given with the square root. The index is 2. And that's why I set this to n equal 2 equal the index of the radical. Okay? And then 3 squared is 9 equal to square root of x plus 5. When you square it, is equal to x plus 5. And now we need to solve for x, so just subtract 5 on both sides. 9 minus 5 is 4 equal to x. This is 0. So x is equal to 4. Let's check if this is a solution. So x equals 4. I'm going to replace this into this equation. X minus 3 plus x plus 5 equal to 4. X minus 3, x plus 5. So replacing this, 2x plus 4 plus 5. Now once we replace the x equal 4 to x, we don't know if the left hand side is still equal to the right hand side. Okay, so I put a question mark. So simplify, we get 4 minus 3 is 1 plus 4 plus 5 is 9, question mark 4. Now, 1, you can rewrite this as 1 square because 1 square is 1, right? The reason I'm rewriting this so that I have the exponent match with the index 2 right here because this is square root. That means I can bring this 1 outside the radical and simplify this. Same thing, I can rewrite this as 3 squared because 3 squared is equal to 9, and if this 3 has the exponent 2 equal to the index 2 right here, I can simplify this square root, question mark 4. So this simplified to 1, this simplified to 3, 4, question mark. So 1 plus 3 is 4, equal to 4. So this is true. So you say that x equal to 4 is the solution. So you say the solution is 4. Okay? So the solution is 4 to this equation in example 6.